Cool.
So we're talking about defensive programming this go around, right?
Yep.
Okay.
Better be.
All right. So who wants to start? Go ahead. Jack, I nominate you.
All right, that's fine. So defensive programming, my understanding is it's a way to code to help make sure that your application is going to continue working under circumstances you may not account for or expect or desire. So if you're coding a user interface, and you've got a form that's asking for your first name or a last name, you're anticipating that users are only going to submit letters. Defensive coding would be preventing users from entering letters, possibly preventing users from entering numbers, or in the lower level code, asserting that the value is only letter based and there are no other types of characters. If there were numbers or special characters, your app could just handle it. It could also blow up. And so without defensive coding, you're not really certain which way it's going to go. Yes?
Yeah, that makes sense to me. I mean, that. Yeah.
Correct.
Omar, we can't hear you anymore.
Hello. Can you hear me now?
Yep.
Okay. So I was just gonna throw out there kind of a quick, kind of concise little definition of defensive programming, and basically straight from Wikipedia. Essentially, is it's basically defensive programming is just an approach in programming to make sure that the software and program continues to function when there's unforeseen circumstances. So stuff that you don't expect to get, input values that you don't expect to happen, weird situations or environments that you're running in that you aren't typically isn't the sunny day scenario, that you should continue to function as normal if you're being defensive.
Yeah, that about sums it up.
Yeah.
You brought up, Omar, the environment, and I guess that the first thought in my head was if you suddenly change operating systems, like if you're writing against Windows and you switch all of a sudden to Linux, your slashes are all of a sudden reversed.
Yeah. Yeah, I mean that's a good good point. That's a scenario you can be defensive in that sense. You can make sure all your paths are, or you have some kind of injection service that all your paths go through or use to create paths to certain files or whatever, to folders. And if they're going through the same service, and that service is configurable, or that service knows to look at the OS before it actually sends back a path or a directory or a file, that's just being extra defensive. And I think there's you can go overboard with being defensive. Like in my mind, what I just explained right there, where you have this service, or you're injecting the service that gives you all these paths that where you can be running on Linux or on Windows, that could be considered going overboard in some cases. Like if you know your software is never going to need to run on anything other than Windows or anything other than a Linux box, there's no reason to be that defensive.
Right.
Yeah. So to me, that was my main observation, is that you can go overboard with being defensive, with defensive programming.
But so why is that bad? Let's say you did have that injection service type thing. Like, why is that a bad thing to have?
To have it, it's a lot of wasted time and effort.
Okay.
Yeah, it's not bad for the software. It's just bad in times of productivity and efficiency.
Chances are you're not. I can't imagine there's too many situations where you're coding something. Well, maybe in Java, but you're coding something that you're targeting at a Linux system and a Windows system, but that you would. I feel like there would be a substantial number of differences between the way those two systems, those two pieces of software would operate. And there might be some code that's, calculation based or that can be combined between the two, but those are probably going to be pretty different situations.
Yeah, I don't know if you're trying to say that it doesn't happen very often. Like I think it
Right.
happens a lot. I just think it's in our case, it happens for we should be mindful of it in some of our cases because we have a lot of cross-platform code now, especially with using Xamarin because we're looking ahead like a few years. We're planning to take our player that's currently only on Android and move it to be able to run on Windows.
Right.
So a lot of that cross-platform code that we're planning to reuse needs to.
Right, but that's my point though, is that we have distinct projects.
Okay, yeah.
Certain projects are .NET Core specific, and then there are some that are they're Android facing. They've got to have Android specific code. Yeah. And so in the Linux situation, we would have another project that would probably be the Linux facing portion as well. So you could still use that the safe code that you can split between the two.
In those examples,
definitely be Linux facing portion. Good.
So in those examples, I mean, I understand you're wanting to code to be as cross-platform as possible, and in some cases you can't. I get what you're saying, Justin. But as far as being defensive goes, let's say we just make an attempt at putting all this Android code on a Windows player. How would you, as a programmer, write the code to be defensive? Do you have it do null checks or just assertions or failures or?
There were a couple interesting things that I looked at as far as ways to not only be defensive, but definitely being over defensive. I think one of these terms is called primitive obsession, which is where you basically are constantly enforcing your validation rules on every method that you're running. And we do this, at least in the legacy code. Almost every method is doing a null check for exactly the same, parameters that are being passed around. And that's something bad. That's being overly defensive. That's something that we do far too often. One of the things that I saw that was a kind of a good way to handle this, I don't know if I wrote this down, but it's essentially you're doing your checks, your null checks, and whatever checks you need to do are designed in the base class and are handled whenever the object is created, so that you know ahead of time when the object is being created if you have a null situation or if you have an integer value that's not in a range that you were expecting or something like that. So you keep all of your checks in one place so that everybody else that's using it, they don't need to continue making those checks.
Yeah, and in the C# world, that's kind of you kind of get the tools or the plumbings in place in order to do that validation in a class, because you can have your kind of getters and setters and make sure your setters are doing that validation on the properties. And so anything else that needs to use it goes through the getter and does that validation for you. So you don't have to check it again once you start using it.
Right.
From outside of that class.
Right. And ideally in a situation which in a project like the Android project that, if that ever gets moved to Windows, I think that project has been developed in such a way that it's not like the legacy code. We're not doing these checks, 1,000 times for basically any one parameter being passed from the top to the bottom. So it going from the Android to the Windows world is probably great. That's probably going to be really nice. But, taking our legacy player, let's say, and trying to finagle that into any other system, would be tough.
Yeah. So I kind of, to your point, Jack, you were asking earlier about being too defensive, or is there any really problem with that, with being?
I know the answer. I was just wondering.
Well, so what I was going to add to it was that that there really is no problem with being too defensive. It's just you kind of take a performance hit if you're doing it too often. Like you can, like say you have this value that you just got from a text input box, whether it be a website or a desktop application or an Android app, whatever. You read in this value, you obviously need to do a validation check on it. But I would say do your validation check at the top level of each service or application that's going to handle that value. So
each layer.
Yeah, the highest or at a top level on each service, because you could have multiple services that you're throwing this data around in. Because like say you take the value from a text input box on a website. You want to do the validation there before you store it in an object, or before you submit that, say at form or text box or whatever. You do the validation there. That's one check. And then you ship that down to the API or whatever, the backend. The backend's going to need to also do at least one validation before it sends it off to the service or whatever is going to persist it or use that value otherwise somewhere else. Or, I mean, it could even go to another API. Say you have, I can't think of a good example, but you can have stuff that could come from like a website and go to an API. That API hits another service. Like if you have like this microservice architecture, that value could be passed around to multiple services. You're going to want to validate it at each service, even though you're the one passing that value and you know you've done the check. You still want to do it at a high level before you pass it down. But once it gets past your high level, I think you should stop doing so many validation checks or stop doing those null checks or those like value checks, like is the integer greater than this or lower than that.
That's kind of the problem we face now, is that almost every method that is written in the legacy base, like the first couple lines are either of these parameters null, return.
Mm-hmm.
But that's being done for every single method. So that same value from the top to the bottom could have been checked whether it's null 15 times before it went from the user to the database.
And unfortunately, it's hard to clean that kind of stuff up because you don't know, like,
well, how many different places it's coming from.
So and you could always obviously find that out, but it's hard to look at all the places and make sure that it's checking it above you and be able to confidently take out that null check.
Well, that's kind of the thing, is you have this feeling like, well, I should, man, they're everywhere, but if somebody didn't check this one path, or my thought is always, somebody probably put this here for a reason, because at some point they were testing and they got a null value somehow.
Yeah, and unfortunately, that's probably not the case.
Right.
What probably happened was someone was going into that, writing that method or whatever, and just was being defensive, because when you're programming, you're just kind of taught to be defensive in your programming, like check for null values before you actually use them. You're kind of just taught to check before, or you always get these null exceptions that you kind of check all the time just to avoid them. And it's kind of along the same lines as like the try catches. Like you get these exceptions all the time. You just want to avoid those exceptions, so you throw a try catch around it, and you just get this try catch in a place where you shouldn't be catching an exception. And I've done this like pretty recently, like within the past year at least. I'd put some try catches at a place in the code where it didn't belong. Like it should have been a lot higher up, because it was at such a low level that it was catching the exceptions and logging them, but at least one caller of that method needed to handle different exceptions different ways. So that bottom level call should have just been doing only what it said it should have been doing. It shouldn't have been doing any other kind of validation, because the top level needed more control over what happened if that went wrong or didn't work.
Jack, are you still able to talk now that you have a new headset? Nope. He said his headset died. I don't know if you noticed that.
Oh, I did not notice that.
No, yeah, he put a little speech bubble up that popped up.
So you can't talk?
Jack's just a listener now.
Maybe you can chat your questions. At least Justin will see them.
So here's my biggest problem with Jack. And interrupt me if I'm wrong.
So I guess I'll start going through some of the notes I kind of went over because
Go for it.
Yeah. So
there are a couple things about defensive programming that are like starkly contradictory.
Okay, go ahead.
Like kind of that, fail fast principle was one of the terminology pieces that I wrote down. Mm-hmm. It's like trying to stop the current operations as soon as possible. But then
I love that.
Yeah. So that's a good idea. But at the exact same time, the next term was the primitive obsession, which is you're over enforcing the validation rules by trying to exit too soon. And it's like, okay, so it's a very delicate balancing act to be appropriately defensive.
Yeah. So I think that was my problem whenever I did that. That example I just gave where I had the try catch too low.
Yeah.
And I had also within that method, I was doing validation checks really high. Like I always do this. I always do my validation checks first thing. Like everyone does. They do the validation checks at the very beginning and fail as soon as you can. And that just really wasn't the way to do it. Because it was such a I don't want to overload the word, but primitive type of call that a lot of different things were going to call into. It needed to just do a very simple thing and not do any checking or anything like that, because other things that called it needed to do that checking first, and we're going to do that checking first, and we're going to need to handle bad situations differently.
Go over a couple of the notes you took, and we'll see where we differ.
I think we differ more. I think we kind of hit a lot of my notes already. Be defensive at a high level, just another way of saying fail quickly. So this one's kind of interesting. Something I wrote down was use database abstractions that protect you from SQL injection. So that was pretty interesting. I hadn't thought of that before. If you use kind of these ORM kind of libraries, they kind of protect you from SQL injection.
Is this something
without you having to do it?
I don't know how often you look at our database code, but is this different than the way we kind of wrap parameters in our execution to the database?
Yeah, I feel like we don't have an ORM. We've kind of basically wrote our own type of ORM, if you will, I guess.
Yeah, we kind of wrote entity
a very specific
in our backend.
Yeah, a very specific ORM to our backend.
Yes. Yeah.
If we need to do something with our database, we don't have to deal with SQL objects or SQL queries as long as it exists. But as soon as a new table exists, schema change exists, you actually have to go edit the SQL text, which you wouldn't have to with an ORM.
Right.
But in most cases, in simple cases. But and we had that problem of SQL injection where we were doing the SQL injection checking. Well, at the very beginning, we weren't doing SQL injection protection or whatever, but we eventually did it at a top level, on the text on the, I think.
Right.
Yeah, we're doing it at a high level anyways. And then lower down our code, our database code wasn't actually doing it. We had places where it was just a SQL string, and you could put a string in there and basic SQL injection. But with an ORM, out of the box, you have this simple SQL injection protection that you don't get if you try to do it yourself, unless you spend a lot of time reinventing a wheel doing it,
which is what we do.
Yeah. Well, we didn't. It's been in there for a while. Well, I guess it's pretty recent actually that SQL injection or doing the parameters instead of kind of a weird string concatenation thing.
Well, this is the royal we I'm using. This is not you and I specifically. I did see the.
I feel like I heard Jack laugh.
He did. He put his headset back on.
Did it work? Okay.
Yeah.
Yeah. I heard you. I realized
I could charge this on the fly.
I did see notes about the database extraction, but I actually didn't stop to read that portion because I was sticking to more. I guess I was being a bit more general than those specific examples. I'll look into more of that later.
Yeah. So a lot of the stuff I kind of wrote down were just kind of tips on being defensive. So like initializing variables. This is something that has always kind of bugged me that sometimes I see that I used to do also, but once I learned about it, I stopped doing it, was not initializing variables. So even if it's like
what is it, like x equals int?
It's like int x colon or semicolon, and it doesn't have like an actual like equal to 0, or it doesn't have like a default value or any kind of value. It's just a variable that has a type. So it's a what's the word for it? It's defined. It's not initialized. Yeah. Whereas if you initialize it, you can check, is it still that default value that you gave it? Like initializing a variable to null. Like at the very least, you're able to check that it's equal to null. Whereas in some cases, you don't necessarily know what it. I guess primitive values are more are a better example. Like with primitive values, you don't necessarily know what it's going to default to unless you in C# you can use the keyword default int. But yeah, I think it's just it's being more explicit on what that value actually is going to be. So
So I'd seen on the Wikipedia page that there's a subset of defensive programming that they called offensive programming. So if you're being defensive, you're handling bad cases in your method. But then offensive programming would be you've identified a bad value and you just reject. You don't try to handle it at all. It passes an assertion error back up to the caller. So basically, if you don't want nulls in your methods, you just do assert values not null, and you'd have to go fix that issue higher up rather than handle it in your lower code.
I don't know if I fully understood that. The offensive coding is just
defensive is attempting to catch every single case
and handle it in your method.
And handle it in your method, or at least have some have some response for every single case.
Okay.
Offensive is more like, here are the cases I handle, and if it doesn't fall in this range, here's the assertion error. Good luck.
Oh, that's interesting, because that's kind of
go.
Yeah, I understood it was defensive programming was what you're describing as offensive coding. So like if I were to do in some cases you would, I think.
Here's the example off the wiki to make it easier for you.
Okay.
There's a switch case that has like traffic lights, red, yellow, green.
And is it just the defensive programming if you Google search for it?
Yeah,
so we can be on the same page? Okay.
Sure, yeah. Go to the defensive programming wiki and then go down to the offensive programming.
Oh, I see. Okay.
And it has the switch case. And so it has a switch case for enumeration of red, yellow, green. And then if none of those hit, it returns black as like the bad value. But the offensive programming example, there you go. The offensive programming example has red, yellow, green catches, but if you hit none of those, it just throws an assert 0 back up, stating that you've basically given a value that was not handled by this method.
Right. So and then there's
both defensive. You're handling this case somehow. The alternative is you don't have the assertion, and whatever happens, you don't know.
Yeah. Instead of asserting, just like throwing some, invalid value exception or something would probably be just as likely to be offensive.
Okay. So I mean, yeah.
I like the assertions better. I used a few last night actually, just making sure that certain directories existed.
And you liked it?
Yeah, so I just did assert os.path exists. And that's it. I didn't have to do I didn't have to handle a case where the path doesn't exist. I don't have to throw a pop-up. I don't have to return an error code or an exception. It's just a one-line assert.
But if the path doesn't exist, what happens?
The method doesn't, the UI doesn't update. The method doesn't proceed. I, as the programmer, know I need to go fix that case higher up in the code. So whatever method is calling the second method, that first method needs to get its act together.
Okay. Interesting. We definitely don't use assertions anywhere.
Yeah, I started using them
Yeah.
recently. Maybe I should put out to the group at work that how everyone feels about assertion, because I already put it in the code base. So
Probably a good idea.
yeah.
Put it out
But
to their
I
own.
felt okay about it because it's a debug assert. So in debug builds or in test builds, it doesn't, or it's there, but in a release build, it is not there.
Right.
So that's what made me feel okay about using it.
Yeah, it's interesting. I don't know. It's interesting. If there's cases those assertions are catching that, let's say they slip through. Say you have a bunch of debug asserts in there and somehow one slips through. Like it's a case that would catch in the debug build, but in a release build, you don't have a catch case for that, and those assertions are no longer valid.
Yeah.
That's it's possibly a place where you could have a serious break.
So something undefined happens.
Something undefined, or something that assertion would have caught, but that scenario just never happened in the test in QA's testing.
Yeah, so I probably should have taken a look at this before actually talking about it, but maybe. But I know it. I put it there. I thought about it for a while before I actually checked it in. Like after I wrote the code, I looked at it and thought about it for a while.
And this is on the Android.
Yeah, it's on the Android side.
And I'd be curious what the Android device even does whenever an assertion pops. Because last time we talked about how assertions show a dialogue and actually give you retry and skip functionality.
I believe it does the same thing. Like it just throws up an Android dialogue. Like yeah.
Okay.
Wait, the dialogue, you don't want that to happen in production. That would be for testing only.
Well, it wouldn't happen in production.
Yeah, it wouldn't. It's a debug
catch
assert.
You wouldn't have the catch case either. So it's. And do you have a keyboard connected to your Android device?
Me? Yeah.
Okay. You get that pop up, you're going to be trying to figure out what the shell command is for any year.
I had to find the XY coordinates on the screen.
My monitor is not touchscreen, man.
Oh, that'd be nice.
See customers on stools trying to tap their displays.
Jesus.
Yeah.
But what do you think about non-debug asserts? So releasable asserts.
Releasable asserts?
Yeah. There's no UI updating. I guess something would get logged. But the method, instead of proceeding, it just stops.
What's the value in using a release assert over using some form of catch in which you handle it, kind of the way we do now? Instead of doing, I guess, a release assert, we kind of catch, log, maybe do some changes, and then return.
I mean, doing the assert would be like the least amount, or doing nothing would be the least amount of effort. Doing the assert would be a little more effort, and then doing a try, catch, and handling would be the most effort.
Do nothing would be the most amount of effort.
So I feel like a release assert, to me, the benefit of using an assert is that you have it in test builds, but you don't have it in production.
Right.
So if you have an assert in production, you're kind of losing the benefit of the assert. Why not just put an exception there? I feel like there's no benefit to using an assert over an exception if you're going to use it in production.
So then why?
If there is, let me know.
Then why even? But then why even do one in the debug scenario, right? If you're already
to get it in the testing phase, and if you don't catch it in the testing phase, then that means it's going to be a very crazy scenario, which
Well, then why are you doing it in a
What are
testing
you going to
phase?
do?
You're also just going to have the try and catch.
That's what I'm asking.
So it's for performance reasons. So the cert gets taken out for performance reasons. You're no longer doing that check. The same reason why it's like being really defensive low level. But you get that benefit of in production, you can take out that check to make it more performant. So it's no longer doing that check there.
So you're assuming that when production is made, if that check was never hit, it clearly was never needed. That's the assumption you're making.
Yes.
Okay.
Yeah.
Well, good luck to you, sir.
So,
well, and just add it's at a very low level. So, like low level, as in like it's a very kind of low down place in the code where if something goes wrong there's something high level that's catching it and preventing the whole thing from blowing up.
Okay.
So Omar, if I can get you to visualize just like a 20-line method, I'm thinking at the very top of the method, you've got, let's say, one parameter. You would perform this release assert on the parameter. That parameter needs to be something allowable. So it cannot be null. It must be within a certain range. That's when you might do a release assert. And then you're doing your try catch further down in that same method when you're calling other methods. So try, call method something else. And if that one throws an assertion error or an exception, then you would handle it at that point. But at the top, you wouldn't do like try parameter 1 is not null. That doesn't make a lot of sense. So you can either assert that the parameter is not null, or you can do a null handling case. And if it's null to begin with, I mean, it's not going to work.
So if you have a method that has a try catch around it, in my head, it should be at a higher level. It shouldn't be too low. And if it is at a low level, you're catching something very specific. You shouldn't be catching a general exception.
Yeah, if you're try catching something, you're searching for like a file that might not exist.
Yeah, the only reason I can think of a try catch like a low level, like a specific example that comes to mind is like, say you have a method that all it does is write to disk, like it's a wrapper around writing to disk. You would have a try catch around that for like permission errors, for file can't write, whatever, stuff like that, like file IO type errors, and only catch that.
So the try catch is for performing some actions, and then the assertion is checking a value. Is that fair?
Try catch is when when there are real opportunities that you're going to get back some
unknown.
You should know what the errors are, but it's like, I'm trying to open a file, but it could be, I could have, for some reason, my software doesn't have permission to open that file, and you're going to get an error back for that, right? So something very, very low. But if you're calling another method that only adds 1 and 1 and then returns, that's never going to fail, and you shouldn't be wrapping those.
In the place where you have a method with the try catch and an assert,
we have something like that.
So I'm still kind of confused on the assert and release builds. Like I don't see the benefit of that versus an exception. Like, why not throw an exception that like if you're checking for a null value, throw a null value exception at that point.
I feel like that's more effort. It's 5 lines of code instead of 1. If all you're going to do is log an error.
If the release assert hits, it must be caught by a try catch block for it to do something.
I feel like we looked this up last time. I can't remember if do asserts get caught by try catches. I remember someone saying that that asserts, they basically stop execution. Like they throw up a dialogue and you can continue or ignore, or like you can abort or ignore. Abort basically stops everything, so that assert never gets caught by anything, and ignore just continues going, hoping it's okay.
Yeah. The debug version of that, you're accurate. It either you have a try, cancel, or continue. You have a retry, cancel, or continue, or something like that.
Yeah. So with that description, if that's accurate, then you're not catching that they're not catching that assert. It just continues the flow of code
That's
or the flow of
debug,
execution.
right? That's the debug version. The release version. That's what we don't know.
Oh, okay.
So last night when I was working on this project, I had the assert at the very top of the method to say assert this path exists,
Mhm.
and I noticed that if the path exists, the method continues, and if the path does not exist, that one method stopped executing, and whatever code called the method just continued.
But that's Python, right? That's
I had it
that
on
might be specific.
event.
That might be the way it handles asserts, and I'm pretty sure in C#, we could be wrong that the release or the release asserts work differently than debugs, but again, still don't know what the value of a release assert is.
Okay, I mean, I don't even know if that's a thing in .NET.
I'm trying to look it up and see if there's.
I think it is because I remember you saying something about like a trace assert or something like that.
That's what it is. It's you use a trace, not a I typed a release. Yeah, it's trace.
But still, even in that case, what's the benefit? Like, why not use an exception? Or what's the benefit of that over an exception?
So a trace assert checks for a condition. If the condition is false, outputs 2 specific messages and displays a message box that shows the call stack. So if you do a trace assert, is this trace? Yeah. You still get like a pop-up that shows a specific, it shows you the error stack. So
okay.
I guess that's bad.
You don't want, you're definitely not going to want that either. This is kind of where we came to the conclusion that asserts are generally bad. Is because I guess they're technically great for testing, but ideally if you're using them in testing, if they're ever hit, you're replacing with something useful, like a log and an exception catch or something. But if they're never hit, it seems like ideally you would just delete them because they're test cases that would never occur. You most definitely never want the dialogue to pop up in either in a release version. You're never going to want that dialogue. So while you definitely wouldn't want them to remain in your release code.
Mm-hmm.
Yeah, given the dialogue, I wouldn't.
All right. So you're either putting them there for debug, for testing. If they get hit, you say, okay, yes, this is a real possibility, and then you change it to do something. If this is null, log an error.
I feel like if it gets hit, in my mind, you leave that assert there just to continue testing, but you fix what was being passed in. So when you have a method with an assert, in my mind at least, when you have a method with an assert at the top, you're not really being as defensive as doing a check there and throwing an exception, or doing a check there and giving that, let's say you're checking for a null value, and if you're being defensive, you would check for the null value. If it's null, you would give that a default value, or you might throw an exception. If you put an assert there, you're no longer being defensive. You're putting a safeguard there for testing purposes only. Okay. And if in the testing phase that assert gets hit, you go and fix the caller of that method to check for that and to make sure that it doesn't pass in a null value.
Yeah.
But that assert stays there.
Okay.
Even if you do a release, say you release that code, and that assert obviously doesn't make it into the release build, but it's still in the source code. So when you go to making or adding on features, fixing bugs or whatever, there's inevitably going to be more callers to that function that could possibly throw or pass in a null value. So I don't think there's any reason to delete that assert or remove it, even if it does get called.
Okay. I'd get behind that.
So Omar, that kind of reminded me of the, what was that term that Steve Taki used? It was to measure how many other methods were calling this one method.
Oh,
fan out.
Yeah, that's what it is.
I wonder if
fan out, fan in. One of the two.
I wonder if measuring like the fan in of a method would be a good way for programmers to determine like where to start putting assertions or any of this stuff in like legacy code.
Yeah.
If one of your guys' methods is being called 100 times, like, go start there. Go fix that one.
Mm-hmm.
Justin, you look puzzled.
I'm just thinking like what it would do. The thing about that is, I don't know. I need to start using asserts to have a real to have a solid idea of what I think would happen, because I can see the pop-up being a real issue doing testing in like stopping your further testing if you have these pop-ups that kind of these assertion pop-ups. But I guess if you have a bug there, you have a bug there. So what's it matter anyways?
Yeah. That's a good way to probably find what methods maybe need asserts, what methods need to do checking, is looking at their fan out, fan in. But I don't think that solves the issue of how we were talking about earlier of you don't really have much confidence going into the legacy code and being able to remove an extra null check because you don't know. It's too difficult to know the callers, like what they're.
Okay.
Because sometimes there could be a caller that's this 100-line method that it's really difficult to follow every single possible way it can call you.
So updating those methods with the huge fan-in numbers, that would have the most value to add assertions and try catches, but those would also be the most difficult because you have all those cases.
Yeah, so it would help you on identifying what methods need to have the asserts or which are the best like candidates to have the asserts, but it wouldn't help you on being confident about adding them there and removing the normal null check.
Yeah, it definitely brings up the possibility of having to fix 100 other methods.
Yeah.
Each one of those is forcing your assert.
I think what would give you the confidence is maybe having unit tests around them. If you had unit tests around them, then maybe you could have. Well, maybe it doesn't.
I don't know. I think before this conversation, I was 100% against using asserts in the code. They didn't seem like they added any real value.
Mm-hmm.
But I think after this conversation, I can see where, at least early in a project for sure,
Mm-hmm.
they have significant value in how easy they are just to pop in.
Yeah.
Because I think, and maybe this is probably not QA, but maybe the developers, when you write a log, you kind of set and forget in a way. You're like, oh, here's a try catch. This is going to pop a log if anything happens. Perfect. Let's keep going. But I can honestly say that I don't check the log files every single time I'm running through the software. But if I had an assertion blow up in my face every single time I was running tests, I'd be like, oh, okay.
Yeah.
Oops.
It's kind of like
it's forcing
big
you to
red flag like that. Yeah.
So I wrote a PowerShell script to basically scan the log files for errors, and they show a pop-up every time there's an error. I basically made an assertion maker.
Yes, exactly what you did.
Yeah.
Okay.
Also, we write errors to the log files that aren't errors. So you're probably getting false flags.
I've added bugs for those, and they're getting reduced to warn messages.
I sure hope so.
No, it's happened already.
Oh, good. Good.
And I guess another positive about that app versus putting in assertions is if you have the assertion, execution stops. And so if my web service stops, but then everything else keeps running, like, is my database tied up in a transaction? Like, are other apps going to start fail cascading?
But do you like, man, that's interesting.
Oh.
Your assertion pops up on whatever machine is running your web service, right?
Yeah.
That is interesting. What happens in services? Like,
I think you don't use assertions.
what?
Right? Fear.
Oh, well.
No, I think there's got to be a better way.
Again, these dialogues only come up in the testing phase. So in production, you wouldn't have this assert dialogue come up in a production server that's running this.
Right, but even still, like I'm saying, if I have an assertion pop up on my server, And like all my other services are requiring this one application to continue working. Like that's going to spawn more errors.
But if this is in QA phase, someone's probably watching somebody better be watching the web service machine, right? Someone knows that and all your other machines. Like if I have a web service that's thrown an assertion and is currently frozen, waiting for that dialog to be handled, and then I'm using my admin and trying to communicate with that thing, I'm probably also getting errors thrown on my end that say like timeout errors or some kind of communication errors.
Yeah, the first thing you're gonna do is go look at your server.
Yeah, and I'm like,
you're
what the
gonna
heck
see
is
a
going
big dialogue.
on? Yeah, exactly. Like, I look at my service, and it's like, hey, so and so assertion debug, and I'd be like, oh, geez, like you're gonna know, but yeah, it's a possibility of 5 other people also knowing you screwed something up at the same time. So
I guess the most value would be on the player side or an admin.
I think it's valuable everywhere. I think you just
Okay.
have to be you definitely have to be paying attention to each machine that is running your software.
Yeah, the more we're talking about them, I don't see very many downsides on the asserts. I'm very
like
pro asserts right now.
Yeah, right. I went from completely against to maybe completely pro, which is a weird shift.
I went to on the line to pro.
Oh, cool.
Yeah.
Didn't expect to get that out of this.
Asserts.
Yeah. An interest in asserts. Another interesting thing that you brought this up earlier, Jack, was the null values. And this pertains specifically to .NET, but there are some interesting, and I'm sure there are Python versions of this as well, but there are actually some interesting libraries that exist for creating, like, this is called Null Guards and maybe structs. These are what the two things are called, or at least the two that I read about were called. And they allow you to basically distinguish very specific nullable parameters that are being passed in. You basically say, like, maybe an int, and then whatever your parameter name is, and that lets it know that it's possibility of it being nullable, but it wraps some other handling around those parameters, and you don't have to do the null check. And the Null Guard as well, which was a library that was on GitHub. You decorate the classes with these. It's basically the same thing. You're decorating the classes and the methods with attributes that state what is and is not allowed to be null. And then whenever it is compiled, essentially, if you said, this is a method, this is an allowed null integer that I call X, and then I have some method that uses it. Whenever it compiles it, it actually creates X as a value that has a getter and setter that do nullification checks in the getter and setter, and then return values appropriately off of that. So you don't have to write all of the getter setter stuff. You just define it with the null guard attribute, and when it compiles, it does it for you. It's pretty interesting. I mean, I've never used them. I don't know how well it actually works, but the concept is interesting.
What were those libraries? For C# or Python?
Yeah. So one is called FODY.nullguard. So FODY.nullguard. And this was on the
Null Guard is the domain?
It sounds really familiar because I think in a lot of in the new C# at least, I think they're doing this already.
Yeah.
Like they're
I'll share the URL here to you guys. There you go. FODY/nullguard. And there's basically an example of how you would set an attribute that allows it to return null, and then when it compiles, it actually shows you what is physically compiled. Yeah, there you go. I like how you can put that up there. So yeah, what gets compiled? So see how it does sets the property, sets a public string.
Yeah, let me go back to what it looked like. So this is before you compile.
Right. So before you compile, you just have some property that's a string, and then you allow it to be null, right, with a getter setter.
Okay.
And then when it compiles it, I'm looking at the null property example, it actually sets a private string that's a null property, a public string that's the null property. The getter, has a value, but it checks that value is null, and then it actually throws an exception for you if it is null. Otherwise, it actually returns the physical value. So it's taking all the legwork of these nasty getter setters out of your hands.
Interesting. But
But this goes back to that defining your catches for your defensive coding in the actual, getter setter of a value, instead of checking it every single time it's being used.
So that the README says it's an add-in for FODI. What is FODI?
I don't know. This was just the example that I found on I think I was actually reading the MSDN page, and this was one of the examples it showed, but I could be wrong. Actually, I'm probably wrong.
So where is this? Where null property on set? Maybe I'm taking too long to. Oh, here we go. So if it's null, it returns it throws an exception.
Yeah, invalid operation.
But
all you did in your code was actually the line right above that. Oh, I guess that one works too. The one you were
decorator?
Yeah, the decorator. That attribute there.
But it says allow null, not do not allow null. that's what's throwing me off.
Can be applied. Okay,
Wouldn't it make more sense to say don't allow null?
So you look at the one below that is what you're looking at, the null property on set, where it says you're just allowing the setter to have a null, and then go down to what we were just looking at. The setter doesn't do anything; it allows a null.
Okay.
The getter, however, was not marked allow null, so it has the check for null and then throws the invalid operation.
Oh, so everywhere that you don't have the allow null. Oh, so this is kind of like a whitelisting.
Yeah, you have to actually tell it this guy's allowed to be null.
I got you. Okay. Oh, so this makes sense now to what the new C# 8, maybe 7, whatever one of the latest ones are. So on the new one, they have, I think they have it now, but they're just putting support into like the Roslyn compiler, the IntelliSense or whatever. They have it now where you can put like a question mark in front of a. Oh no. Yeah, they have it now where you can make primitives nullable, where normally primitives aren't nullable. They have it where you can put a question mark in front of a primitive and it allows it to be null. Now what they're doing is you can put that question mark in front of an object type. So if you're creating like a foobar object, you can put a question mark in front of the type. Say the type's foo, you put a question mark in front of foo, and anywhere you're using that value, if you like do a dot operator, like call a method on that object, and you haven't initialized that object, or you reset it to null or something like that, and you try to use it before doing a null check, it throws like a squiggly underneath it, and you can set in your Visual Studio properties, say like throw an exception if you aren't doing a null check around these things, or only do warnings, or just.
Interesting.
Yeah.
So this is actually in the IntelliSense. It actually knows.
Yeah, I think they're adding. They're adding.
Grumpy.
They're adding the support into Roslyn to.
Oh, that's cool.
To kind of do it on the fly without you actually having to hit the compile button. Like as you're writing it, it'll have a little squiggly underneath it.
Oh wow! Because I mean, it's been a relatively recent version where you could do something like if you had some object, you could put a question mark in front of it, dot some property on that question mark, dot, and eventually that essentially says if any of these are null, stop.
Yeah, the Elvis operator.
Yeah, is that what that's called?
I think so.
Oh, instead of having to say, if object is null, stop, or if object dot count or a dot list is null, stop, or if like so on and such forth, you just put the question marks.
Yeah, in the very beginning, I loved that operator. Now I'm feeling like it's getting abused. like I feel like because you kind of do this because that's kind of being defensive, doing that, using that operator. And if you do it all the time, you're kind of doing the same thing as doing an if null, do this, or if not null, do this at every spot that you're doing that Elvis operator. And I've gone back and seen some of my code. And I'm like overusing that Elvis operator because it was in the early days when the C#7 or whenever they introduced that not too long ago, at least to us. And yeah, I'm doing it like one method and then passing that object to another method. And I'm also using the Elvis operator where if I just did the one check at the high level, I wouldn't have to use it down there. And it just, you kind of get that small performance gain.
I'm not sure where it got the term Elvis operator from. I searched Elvis operator and I found it, but what it's really called is the safe navigation operator.
I like Elvis operator better.
Elvis operator is better. I don't know how it got that name, but the example here really drives home the use because it says, if item's not equal to null, then item equals the child, and if that item's not equal to null, then that equals the child, and if that's not equal to null, then you got your object. And then the next example.
If you do oh, I see why. It's its hair. If you do a Elvis operator search and click images.
Oh, it's supposed to be the curl off the front of his head?
Yeah.
Oh, Jesus. Okay. Wow. Okay.
Yeah. And then there's also the other one that's pretty similar, the null coalescing operator, which is the double question marks.
So that was C#6.
Oh, was it?
Yeah, so it's the question mark dot and the question mark open close square brackets. I didn't know you could do that. And then null coalescing, which what you just said is double question mark, and I don't know what that is either.
You know what the null coalescing? So the null coalescing is where it's kind of like a default. So it's syntactic sugar around if null this, basically.
Okay, so int length equals people.length question mark 0. So if length is null, then we're just gonna go ahead and say length is 0. Okay, interesting.
I don't know how to spell coalescing.
Coalescing. Coalescing. Esking. Okay. So, yeah. So this, yeah. Okay. Yeah. So instead of having to say if length equal to null, so it's kind of like instead of doing the question mark and then the colon, to say that we're basically instead of checking if this is null, then if it's not null, return the value. Otherwise, return 0. Instead of doing that, you just say question mark 0.
Yeah.
That's nice. I didn't know that existed.
Yeah. But then again, I feel like that gets some abuse also. It gets overly used. I think I at fault for it also. It kind of gets overused the same way the Elvis operator does.
There are some times when you need to know if a value is null and you need to react.
Right.
But there are plenty of other times when you don't. Maybe you just need to know if it's null, then that's okay. You just need a defaulted value. So I guess too much of anything can be a bad thing, but there are definitely very strong use cases for all of these little.
Yeah. Well, and I think like using it, like it's kind of like being defensive without really needing to, I guess. Like, say you do a null coalescing and then you do an Elvis operator on the same object, like you already defaulted to that value to something. So there's no need to use the Elvis operator because you know the object that you're using has a value to it because you just defaulted it to something.
Yeah, well, this example uses not only the Elvis operator but the null coalescing, and it says int length equals people question mark dot length question mark 0. So it's using it to say, well, people's null, then 0, but also if length is null.
See, that's a perfect case. That's like a good case of using it right. What I was saying is kind of the opposite. Like if you were say you ran that, and then whatever you threw that value into,
Yeah, that
later on you did another check for it. Like it's kind of redundant, and
Yeah.
you lose some performance, and it's
Yeah.
And it just starts to look ugly if you have these Elvis operators everywhere. That's what I started.
Just question marks everywhere.
Yeah.
What version of C# are we using on the legacy project?
6.
Actually, we can't be using 6, are we?
I'm guessing.
I
If
feel
you're
like I got-
talking about like our legacy project, it's like 5 or 6. Yeah.
Okay, because I got some code rejected the other day because I did the functional method definition where I said like, some static value, some static method was supposed to return some version comparison using the fuzzy logic. And so it was taking 2 string version values and making a comparison. And I just had the arrow operator util fuzzy logic comparison, blah, blah, blah.
Oh, you're talking about the
Yeah. So what version is the arrow operator in?
or whatever.
Yeah.
Expression bodies. Yeah, that's C#7, I think, or
Is it?
yeah, I'm pretty sure it's 7, and it's called an expression body.
Oh,
Where like you have a one-liner method, and instead of doing the curly braces, you just do a lambda.
exactly.
Yeah.
I did that and it got rejected.
Yeah.
So that's version 7 that exists in?
I think so. And I'm pretty sure 7 is the most recent one that we're using. And I think 8 is out.
So it was added for get accessors in C#6 and was expanded to constructors and finalizers and everything else in 7.
Right. So we're definitely using at least 7 because I'm pretty sure we have some constructors.
Not in legacy, but in
in the newer projects. Yeah.
in the Android stuff, definitely. Yeah.
Yeah.
Because I've written a bunch of functions using it on the Android project.
Yeah.
Okay. I never thought to use it in getter and setter. That is a cool place to use it as well.
Yeah. I think that's like the main place where I've seen it used, and it's in getters and setters. Because most of the time you're doing some one-line thing for getters and setters.
It's used a ton in the show logic for actually like drawing things on screen. Or maybe
it's very possible. I don't remember.
Okay.
All right. So is there anything else on defensive coding? I don't know. I think I went over my notes, or at least y'all hit the points on my notes.
I touched everything that I took notes on.
I'm good.
All right, cool. Well, that was a good talk. That what I got from it was we need to start asserting stuff.
Yeah. I'm going to start using assertions earlier in projects for sure. Yeah. I think it might be beneficial. Might bring a discussion to everybody else and see what people think.
Yeah, I think that'd be a good idea because I've already used at least one place.
So better to get forgiveness than ask permission. Good job.
Yeah.
Omar, would yours actually throw a pop-up?
I don't know. It hasn't failed. So
what you need to do is write like the fail case right before the assertion, and then run it on your machine and see.
Yeah, that's what I'll probably do tomorrow. Like morning is run, or maybe even just turn it opposite of what it should be so that it fails automatically.
Yeah. Oh, yeah, that works too.
Yeah, we'll see what happens.
Okay. All right, cool.
All right, cool. Bye. Talk to you guys tomorrow.
Yep, see you.